Welcome back from a short break. So now let's continue. So now we're going to be looking at our application questions, and they are still based on the density, mass, and volume. Let's start. We are given 3 states of matter here, and we're supposed to compare these 3 identical containers below. We have solid, liquid, and gas. Question is, which container contains the greatest number of particles? And which container contains the smallest number of particles? So now, we know from the get-go. So let's start, we're going to say greatest. And we're going to say then smallest. So now, we know from the get-go that the gas particles, or the container that has the gas particles within that container, they are the least number as compared to the solids and the liquid. So therefore, the container that contains the smallest number of particles would be the gas container. Let's write it nicely. Container. Container. And then now we need to now check between the solids and the liquid, which one has the greatest number of particles. So remember that the particles in a solid are closely packed together as compared to the particles in a liquid. So now by that, it would mean that the solid container would contain more number of particles as compared to the liquid, because there are spaces between the particles, which means that there's going to be less particles as compared to the solids. So now the container that contains the greatest number of particles would be the solid container. The solid container. Now, our next question. Again, we are comparing the 3 identical containers below. We have the solid, liquid, and gas. Question is, which state has the highest density and which state has the lowest density? And we need to give a reason for our answer. So number 1, what we remember about the density is that the substances that are more heavier will contain or will have the highest density. And the substances which are the least heavier will have the least or the smallest or the lowest density. And we also know that the particles in a solid, there's more of them. We just said that now, that there's more particles in a solid. And if there's more particles in a solid, it then means that solid is going to be heavier. So if it's heavier, it means the density is going to be higher. But then remember that water is an exception to this. That the water particles, the water as compared to the ice, the density is slightly different from what we are saying right now. In this case, we're saying that the solids, in this case, they are going to be more denser than the liquid and gases. But when talking about water, it's quite the opposite, that the liquids are going to be more denser than the ice or the solid part of the water. So in this case, we're not talking about water, we're just talking about solids, liquids, and gases in general. So therefore, the substances or the state that has the highest density is going to be the solid. So highest density. This is going to be the solid. And then the lowest density that is going to be the gas. Remember that water is an exception to this rule. Now, question 3 is asking us, and we are told that we are given a brick and a loaf of bread that are the same size. Would the brick or the bread have a greater density? So when we are looking at the bread and looking at the brick, we know that the brick is much heavier than the loaf of bread. So therefore, by that, we have only that to go by, that the brick is heavier than the bread. So that means the brick will have a greater density. So would the brick or the bread have a greater density? That would be the brick would have a a greater density. There we go. Then question 4. Which one between the two, the brick or the loaf of bread, has more mass? Remember, if a substance has more mass, it will have a greater density. And if a substance has a greater density, it will have more mass. So we just said that now that our brick will have a greater density, which then translates to a greater mass or more mass. So brick has more mass. We need to remember that the relationship between density and mass, when the density increases, the mass also increases. So if a substance has a greater density, it will also have a greater mass. But the relationship between the density and the volume, when the density increases, the volume is going to be decreasing. Question 5. Which one would have the greatest density? We did say that it is the brick, but then now what do they want? They want us to explain our answer. Why do we say that the brick will have a greater density? So, to start by answering the first part of the question, which one would have the greatest density? We'll just say that's a brick. Now, why do we say that? Why do we say that the brick has a greater density? Now, the brick is heavier than the loaf of bread. And because of that, the density of the brick is going to be greater than the density of the loaf of bread. Now, question 6. Use the particle model of matter to explain why solids. So remember, we are using the particle model of matter, and with that, we're going to explain why solids have a fixed shape, but gases fill the shape of the container they are in. Now, let's think for a bit. The particle model of matter tells us that all matter is made up of particles, and those particles are always in a constant motion. And now that means if we are talking about the solids, we know that the forces of attraction between the particles of a solid, they are more greater as compared to the other states of matter. And because of that, the particles are closely packed together. And if they're closely packed together, that means they're going to have a fixed shape, because they are not going to be able to move around as they please within the container. They're just going to be vibrating around or about a fixed point. So now let's write that down. Use the particle model of matter to explain why solids have a fixed shape. So solids. They have the greatest forces of attraction between particles. As a result, the particles are closely packed together. And they vibrate. They're closely packed together, and then they're going to be vibrating around a fixed point. There we go. Then what about now the gas particles? They're going to vibrate around a fixed point. Now, what about the gas particles? The gas particles, we know that it's the opposite of this. They have the least force of attraction between the particles, and because of that, the particles of a gas are free to expand and move and fill the container that they are in, and therefore they move around freely within the container. They do not vibrate around a fixed point. So, how do we then write that? Let's erase this. And then talk about the particles of a gas. Remember, the particles of a gas, they fill whichever container that they are in, and the forces of attraction between the particles are very, very, very small. They are almost non-existent, and therefore the particles are free to move around and fill the entire space of the container. So gases. The least amount of attractive forces particles move freely and fill the entire space and fill the container they are in. And because of the least amount of attractive forces, they're able to move around freely within that container that they are in. So that is why the gas particles, they do not have a fixed shape because they are free to move around in the entire container, whereas the solid particles, they have a fixed shape because the forces of attraction between the particles, it is so big to a point that those particles are closely packed together, and because of that, they just vibrate around a fixed point. Next question. We now need to use the particle model of matter to explain why you can compress a gas easily, but you cannot compress a liquid very easily. So why is that the case? Remember, when we are looking at the gas particles has large spaces between their particles, has large spaces between particles, whereas the liquids, they have small spaces between the particles. And because of that, it's easier to squeeze the gas particles because they have a very big space between the particles as compared to you squeezing the liquid particles because the spaces between those particular particles is very, very, very small. And because of that now, it's easier, as you have said, you cannot compress a liquid very easily. So learners, before we continue, we're just going to quickly go for a short break and I'll see you just after this.